Challenges and opportunities of carbon nanomaterials for biofuel cells and supercapacitors. Personalized energy for futuristic self-sustainable devices. By Itthipon, Jeerapan and Nicolás. Hello everyone and welcome to the Itthipum podcast, where in this episode, we discuss science, engineering, and technology. In today's episode, we are going to discuss the introduction of applying carbon nanomaterials for biofuel cells and supercapacitors. Personalized energy for futuristic self-sustainable devices. Various carbon allotropes are fundamental components in electrochemical energy conversion and energy storage devices, such as biofuel cells, or BFC, and supercapacitors. Recently, biodevices, particularly wearable and implantable devices, are of distinct interest in biomedical, fitness, academic, and industrial fields due to their new fascinating capabilities for personalized applications. However, all biodevices require a sustainable source of energy, bringing widespread attention to energy research. So, what should we do? Let's see some introduction today. With the increasing development of electronic and bioelectronic technologies, electrical energy conversion and storage are recognized as crucial divisions. Carbon materials have opened up new opportunities for efficient energy conversion and storage, particularly biofuel cells, which we can call it BFC, and supercapacitors. Carbon and its various allotropes have been the lifeblood of these technologies, in the sense that their chemical and electronic properties have long been explored for expediting these developments. From their use as a benign high surface area and electronically conductive support for electrochemical energy devices to their role in revolutionizing BFC and supercapacitor technologies, special attention must be given to certain carbon developments. Some of these include nanostructured carbon supports and tailored surface chemistry carbon materials, particularly CNTs and graphene, as energy materials. These advancements possess unique properties useful for enhancing energy conversion, that is, biofuel cells, and energy storage, that is, supercapacitors, performances. More recent use of carbon for energy applications can be seen in technologies for personalized use, such as miniaturized, portable, wearable, or implantable applications. Electrodes with carbon materials and their composites functionalized for charge collection are highly attractive for use in personalized energy harvesting technologies due to their outstanding electrochemical properties, electrical conductivity, and flexibility. In addition, carbonaceous nanomaterials have been applied to establish bionano interfaces, in order to optimize electron transfer processes in biofuel cells that require competent electrochemical communication between enzymes and carbon nanomaterials. This makes carbon materials an attractive option for the future development of flexible, stretchable, and personalized energy electronics. By paying proper attention to key obstacles and leveraging the advantages of carbon materials, these innovations could have a tremendous impact on electrochemical energy-related applications. Yes, personalized electronics, particularly wearables and implantables, play a significant role in many fields in the modern age. Emerging electronic devices, such as wearables, are not only relegated to entertainment but provide features such as biosensing capabilities, which have been garnering substantial attention in both industrial and academic fields because of their increasingly viable applications. These also include biomedical devices, artificial skin, and soft robotics incorporating arbitrarily shaped surfaces. Further examples of wearable applications extend to biosensors, where the sensors can ideally interact and communicate with their environment. The personalized electronic field benefits from the advent of these devices, being able to incorporate flexible circuits, conformable and flexible displays, electronic paper, touch screens, and skin-like sensing capabilities into data collection and large-scale healthcare. Personalized electronics have quickly crossed into digital health territory in various biomedical applications, including tracking the various vital signs of wearers with the intention of improving their community's healthcare. In addition to biomedical implantable devices, some of these technologies have become part of our contemporary lives in the form of wearable accessories such as smartwatches, armbands, and glasses. Therefore, the ever-growing demand for developing effective personalized energy devices is at an all-time high to power said biomedical electronics. Alright. In order to ensure the sustainability of the bioelectronic system, the corresponding personalized power sources must deliver a stable and persistent electricity output. These devices should maintain satisfactory performances under real conditions and in real scenarios such as biocompatibility, small size, light, stretchability, and mechanical resiliency. This podcast reviews the progress of innovative supercapacitors and biofuel cells that have been developed toward personalized applications. Supercapacitors have recently been brought to the forefront of energy source alternatives for individual applications due to their fast charge, discharge capacity, long cycle life, and safety. These energy storage devices are required for powering any desired electronics. As a result, supercapacitors play a vital role in biomedical and personalized applications, overcoming the limitation of needing a constant supply of energy. In addition to supercapacitors that can store energy harvesting devices can also incorporate conformal supercapacitors to store the generated energy. This energy can then be utilized to power a variety of personalized devices, such as wearable sensors. Biofuel cells represent another important category, that is, energy harvesting devices, in particular, for personal and biomedical applications. Biofuel cells, which convert biochemical energy into electrical energy using the assistance of biological components, in particular, enzymes, provide an emerging, green, alternative for numerous wearable and implantable applications. Biofluids, such as sweat, tears, interstitial fluid, and blood, contain useful metabolites, such as glucose and lactate, that can be used as fuel for personalized biofuel cells to generate electrical energy. Interestingly, biofuel cells can also be designed to act as efficient, self-powered sensors, allowing these systems to mandate lower energy requirements as compared to conventional electrochemical sensors. Well, although researchers are continuing to develop new energy devices based on a variety of carbon materials, there is a continuing need to improve these applications. Revolutionizing traditional carbon electrodes toward personalized application requires careful engineering to address several key limitations. Alright. Please see this figure showing right here, which will be discussed in our review podcast. Yeah, let's see this figure. The figure on the left shows the illustration of the applications of carbon nanomaterials and composites for electrochemical energy devices. See? This figure on the right shows you several examples of challenges in the development of carbon-based supercapacitors and biofuel cells toward personalized applications, such as wearable and implantable purposes. Okay, right? Many of these challenges include concepts relating to nanoengineering, electrochemistry, and material science. For example, optimizing the electron transfer between the reactive site and carbon electrode requires different electrical wiring techniques, which has a primary impact on the enhancement of biocatalytic biofuel cells. Oxygen also holds a strong role in the cathode compartment in biofuel cells. This leads to a predicament where oxygen is needed to enhance the power efficiency, while accounting for fluctuating oxygen conditions to improve the oxygen reduction of the cathode. Yes? Moreover, another catalytic is developing strategies to improve the efficacy of the biofuel consumption at the enzymatic active site, which can be achieved by stabilizing the enzymes, biocatalytic activity, and active materials within the carbon electrode. Another requirement is to optimize the surface area of the electrode at electrochemically accessible locations by carefully engineering the architecture and porosity of the carbon-based materials. Furthermore, for bio-integrations with the curvature of the human body, such as for wearable and implantable applications, there is a challenge to improve on the flexibility of traditional energy biodevices. The devices must incorporate mechanical resiliency while maintaining good electrochemical functionalities of carbon-based devices. More attention to these types of challenges, which will be detailed in this podcast, will have a major positive impact in the wearable technology and other personalized energy-related bioelectronics. This perspective review podcast aims to cover the progress made in emerging personalized biofuel cells and supercapacitors that have utilized carbon materials. First, we provide a detailed overview of the principles and material aspects of the components in energy-related devices, including supercapacitors, biofuel cells, and innovative self-powered biosensing devices. We summarize the progress of reported developments in energy devices, which are based on carbon nanomaterials. As well as discussing important achievements in the field of personalized carbon-based energy devices, we also illustrate the challenges that currently hinder further developments. This podcast focuses on presenting examples of carbon-based energy systems to address key challenges in the field. Finally, we discuss the future perspectives and remaining challenges toward the practical application of personalized, miniaturized, and/or conformal supercapacitors, biofuel cells, and self-powered biosensing devices with reliable mechanical functionality and stable electrochemical performance. This application occurs under the strain of repeated personal use, such as modern digital health and other practical energy requiring biomedical applications, that is, biosensing, diagnosing and therapeutic management. In addition to personal applications, advancements in carbon research toward energy applications will greatly impact various domains of high-performing energy device developments with special characteristics. Alright? Next episode, we'll continue to discuss further how to move supercapacitors toward personalized platforms. Be sure to listen all the way through for the details. Do you have questions or comments? Or, want to ask a question on a future episode of Podcasting Q&A? Hope we can find time to continue it soon. Please feel free to leave your comments here. Thank you. Many thanks. See you. Thanks so much for joining us. Do you like our podcast?